Hey, wonderful class. Here we go. We're going to review this test so that you guys can be prepared for your test on Friday. Some of them I'll just whiz through very quickly. It's a long test, so I don't want to make this video epic, but it's for you to use as you need to. So that means pause, rewind, go back and watch something if it doesn't make sense. But a lot of you I've already noticed have done pretty well on it. So you may not need too much review. You can just kind of fast forward to figure out where the problems are that you'd like some extra review on. Okay, most of you are pretty clear with these. So we got, a 90-degree angle is like the corner of a piece of paper. Anything greater than that, but still less than 180, is what we call an obtuse. So between 90 and 180 is obtuse. Remember, angle degrees are measurements of rotation. So if that's your center of rotation here and these two lines are connected to it and we rotate that, we measure how far that's rotated, and in this case it'd be more than 90 but less than 180, so that is obtuse. All right. Okay, and then in between 0 and 90 degrees would be acute, a cute little angle. All right, we have this little box in here that tells you exactly what it is, which means that has to be 90 degrees, so we call that a right angle. All right, vertical angles, whenever two lines cross, angles that are opposite each other are called vertical. And we know another thing about those, they're always congruent. They're always the same measurement as well. So let's look at these pairs. 3 and 4, 3 over here and 4 here, they're not opposite each other. They actually share a side. They're next to, which means they're adjacent. So that is not right. 4 and 6, all right, 4 and 6, opposite each other. They don't overlap. They don't share a side, and they would be congruent. There we have it. All right, 3 and 6 are next to each other. 4 and 5 next to each other. They're adjacent angles. All right. Here we're asking for vertical again, so opposite angles that are opposite each other when two lines cross. So our first one is 1 and 8. Looks like they're next to each other. They share a side or a ray. This guy here. So they're not good. 7 and 8 share this ray. They're next to each other. Not good. 2 and 7 are next to each other again. Nope. 1 and 7 are opposite each other. Yup. There you go. Vertical angles. Now we're looking for the adjacent angles. So let's check it out. 4 and 6. No, those are vertical angles. Here and here. 3 and 5, 3 here, 5 here, no. All right, 3 and 4, ooh, that's got potential. 3 and 4, we call those linear pairs. Remember that at all? This angle 3 and this angle 4, when put together, create a straight line. Now that's just extra. That's not part of this problem, but so that one's good. Let's check about 5 and 6. 5 and 6, also a linear pair, but they share that. This guy here, they share that. They're next to each other, and they share a vertex. So they share a side and a vertex. So there we go. Both of those are correct. Nice. All right, moving on. We have, we're looking for adjacent again. In this case, let's look at A first. 3 and 5 are opposite each other. 1 and 7 are opposite each other, so they're vertical, no good. Ooh, C says 1 and 3, they share a vertex and they share a side. So that's one that's good. And then 3 and 7, oh no. Oh yes, they share a vertex, right, here and here, and they share this side. So there we go, we have that one. D, if you look at that, 3 and 5 are vertical angles, so that's not good. All right. Okay. Identify the pair of angles as complementary, supplementary, both, or neither. This can be a little, excuse me, confusing because it doesn't really indicate what angles they're talking about. So I'll draw it on here. This angle and this angle. All right, so we have this angle here, and then we have this angle here, and together it looks like they create this 180-degree angle around that vertex. So therefore, when two angles combine to make a straight angle or 180-degree angle, they are supplementary. All right, moving on. Okay, well now this is obvious because you have a pair, two angles. Some of you would see a 90-degree angle and immediately think, ooh, 90 degrees, that's got to be complementary. But it's asking you if we add these two up, 90 plus 90, we get 180. And whenever the sum of two angles is 180, we have supplementary angles again. All right, moving fast here. Which of the following statements is true? Angle B and angle D are supplementary. Well, they look like acute angles, and you can't add up acute angles and get 180. You can't add up two things less than 90 and get 180, so no. They're vertical angles, they'd be congruent to each other, but they aren't supplementary. B and D, let's see if B and D, angle B, oh, that's just the opposite of what it just said. Okay, so no, they're not complementary either. We don't know if they're complementary. It doesn't look like they're 45 degrees. That's the only way they could be 90, because 45 plus 45 is 90. We don't know what their measurements are, so we don't know if they're complementary. A and B here are supplementary. Well, it looks like there are special situation where we have adjacent angles, right? They share a vertex, they share a side, and their non-shared sides shoot off and create a straight angle. So if we put this rotation together with this rotation, it spreads out wide enough to 180 degrees. So yes, that is true. Part C, they are not complementary. They're supplementary. All right, moving on. Keep it going. All right, find the value of x in the figure. Well, we are going to look at this angle and this angle. And we know that those are linear pairs. They share this side, they share this vertex, and their opposite, their unshared, their non-shared sides shoot out that way and that way to make 180. So you see, this is 78. How much more would it need to complete that 180 degree rotation? So what we'll do is we'll say x, let me sign in, x plus 78 equals 180, and we'll solve that by using inverse operations to isolate the variable. I'm sure you guys are tired of me saying that, but hopefully it sinks in and sticks. So that would be 102, and that's A. All right, next. Ooh, number 12. We got to find x, and the special relationship here is that the angle that measures x degrees is vertical to the angle that measures 147, and vertical angles are always congruent or equal. So therefore, we have these are equal, so x must be 47. Moving on. Ooh, this looks fun. So we have this angle and this angle are adjacent because they share a vertex and they share this side, right? And then their non-shared sides, right? They're non-shared sides of this angle, so this guy there, the non-shared side, and the non-shared side of the other angle, this guy there, they create this 90 degree angle. So that means together the 40 degrees and the x degrees have to equal 90. So that gives us x plus 40 have to equal 90. Let's isolate the variable by using inverse operations and subtract to isolate x and get 50 degrees. All right, moving on. My drawings are so beautiful. Number 14. Okay, so now this one's one where it doesn't have a picture. We just have to use the words to help us. So if the measure of angle A is 44 degrees and angle A and angle B are complementary, so they have to add to 90 degrees, what is the measure of angle B? Well, you might be able to do it mentally. You might say, well, let's see, if A is 44 plus what for B would equal 90, or you can write out, you can say, well, angle B plus 44 equals 90, and then we're going to subtract the 44, and we get B equals 46. Okay, because that's what adds to 44 to get 90, so 46 is our answer there. And the idea is that you have to understand this word right there. If you know that, then you know what to do. All right, here's a very similar problem, except they change the word. They say angle A and B are supplementary, so therefore their measures must add to 180. They tell you the measure of A, and you have to find the measure of angle B. So the measure of angle B plus 154 equals 180. Isolate the variable by using inverse operations. Minus 154, B equals, and that comes to 26. So we have that guy right there. All right, remember, pause and rewind if you need to. Okay, classify each triangle by its angles and by its sides. So it's angles and sides. Now there's three names for the angles. There's, oh, now I'm forgetting them. Okay, there are acute, there's right, and there is obtuse. So you need to choose one name from that list, and then you also need to get one name from the side classifications, which would be scalene, no sides are equal, isosceles, which means two sides are equal. Oopsie. Isosceles. I think it's like that. And, oh, right, it's right here. There it is. Yeah, that was right. Okay, and we have equilateral, which means all side lengths are equal. Equilateral. All right. So let's look at this. Looks like all the angles, 60, 60, and 60, are less than 90. So all the angles are less than 90, so that's acute. And then the three sides are equal. That's what these little dashes mean. If they have the same number of dashes, then they're congruent or equal. So that's an equilateral triangle. So acute equilateral gives us part D. There we go. Moving on. Let's check this one out. So we need the three. We have to classify it by its angles. And it's a right triangle because it has one right angle. Hey, challenge for you. Try to make a triangle with two right angles and see what happens. Anyway, it has one right angle, so it's right. And it looks like this side and this side might be the same, but I don't think so. It looks like this guy's longer. So 3, 4, and this is greater than 4 probably. So they're all different sides. So that's going to be right scalene. All right, we're almost to the 20s, man. We're getting there. Okay, we have to find the missing measure in each triangle. This will be fun. All right, we have a rule here that the three angles of a triangle always add up to 180. They always add up to 180. This one can be tricky because you forget that this little square here means 90. So just fill that in. And then we have 90 plus 38 plus x equals 180. So when it says find the missing measure in a triangle, well, you're going to be using this setup here. You're going to be adding the three angles to equal 180. When you do it, you get 128 plus x equals 180. And we're going to isolate the variable by using inverse operations. All right. Okay, and that comes to, let's see, 52 degrees. And there we have B, 52. All right, same situation here. We're going to add up 56, 63, and x, and they have to equal 180 because the angles of a triangle always add up to 180. And we're going to simplify by adding like terms here. So that gives us 119 equals 180. And then cancel out this 119. We get 61 degrees. All right. Okay, now these ones could be a little bit tricky. I wish I had my my calculator on me, because these can be tricky. See if I can do them mentally. You might hear me typing away on my computer to use a calculator. A map has a scale of 3.5 inches equals 20 kilometers. If the distance between two cities on the map is 4.9 inches, what is the actual distance between the cities? All right, well, we're going to put this into a proportion. 3.5 inches goes with 20 kilometers. And then they give us that on the map, the cities are 4.9 inches apart. And they tell us what is the actual distance between the cities. So we're wondering how far in kilometers that's apart. So this, I am going to use my computer here for my calculator. And let's see, so what do we have to do? We're going to cross multiply. We're going to get 3.5x equals, and let's do 20 times 4.9, and that gives us 98 over here. Okay, and now we have to divide by 3.5, divide by 3.5, x equals, and I get divided by 3.5 equals 28. All right, well, that worked out nicely, 28 kilometers. All right, here we have another one. So an architect's blueprint for a new house shows the kitchen being 7 inches wide. If the scale used to create the blueprint is a half an inch equals 1 foot, what is the actual width of the kitchen? So we'll put that scale into a ratio here. And then we will write the ratio of the one we're trying to figure out. So it says the blueprint, the kitchen is 7 inches wide. We have to make sure that we match up the numerator with the same type of unit and the same, if the top is about the blueprint, then the top of the other fraction has to be talking about the blueprint. And then it says, what is the actual width? So we're going to put an X down here in feet. Okay. So here you see that this is talking about actual and this is talking about actual. All right, so that's one of the keys with proportions is you have to, the numerators have to be the same, the denominators have to be the same, they have to be the same units and talking about the same thing. All right, now we're gonna rock and roll here and get 0.5x, cross multiply here and get 7, and then we're going to divide by 0.5 and divide by 0.5, and x equals 14. And what is that? That's going to be 14 feet. All right. Okay, now these ones should be a little bit quicker. Identify each solid, name the faces, edges, and vertices. So first we have to name the solid, all right? And some of the key things about this shape is that it has triangular faces that go up and meet, right? what's that, 4 triangular faces that go up and meet at this vertex here, at this vertex. Okay, when they have a bunch of triangular faces that meet at a vertex, and then they have another shape, right, where all the triangles are attached to, that is a pyramid. All right, so this is what we call the base, and no matter which way we flip or turn or spin this thing, the non-triangular face is the base. Okay, and then these triangular faces are called lateral faces. All right, now we are going to count up the faces first. Okay, so we have, like I showed, we have 4 triangles and 1 base, so that's excuse me, that's 5 faces. Okay, the edges are where 2 faces meet. So we have an edge 1, 2, 3, 4, 5, 6, 7, 8 edges. And then the vertices are where 3 or more edges meet. So we have a corner here, a corner here, a corner here, and a corner here, and then one up top here. So that gives us 5 vertices. All right, so then we look down here and notice that we have a pyramid with 5, 8, 5, so that's this one here. All right. Okay, so hopefully you know your 2-dimensional shapes, because you needed to know that kind of for this. Anyway, so this shape is actually not sitting on its base or its bases. In this shape, we notice that we have this hexagon and this hexagon, matching hexagons that are parallel to each other. All right, so when it has matching parallel faces like this one does, with this guy here and this guy here, that's going to be a prism. All right, and how are those 2 parallel faces connected? They're connected with a bunch of rectangles. Okay, rectangles that kind of wrap around those 2 shapes and connect them. So whenever you have 2 parallel congruent faces connected by a bunch of rectangles, that's going to be a prism every time. All right, these faces that we indicated are your bases. These non-rectangle faces are your bases. Okay, so this is a hexagonal prism, so it's either this one or this one. And we are going to count up now the faces. It looks like we don't have to count the faces because they both say 8. So we can skip that. Let's look at the edges. All right, so we have, I'm going to mark off the edges here. There's 1, 2, 3, 4, 5, 6. And then there's 1, 2, 3, 4, 5, 6 on that side. And then each of these corners, right, has to be connected to the other corner by an edge. So since there's 6 corners, that means there's going to be 6 lines going this way. 2, 3, 4, 5, and then there's 1 back here, up here, 6. Okay, so that's 6, 6, and 6, which is going to be 18. So that's our answer there. All right, we can also do the vertices, which is, there's going to be 6 here and 6 back here. All right, go, go, go. I want to take up the whole day with this video. All right, let's figure out what this is. So, do you see 2 parallel faces? What shape are they? All right, your tendency is to say, well, it's sitting on this, so it must be a rectangular something. And it looks like it goes up to a point. I see some other triangles, so maybe it's a rectangular pyramid. Well, that would be incorrect. All right, what you need to see here is that these 2, this triangle and this triangle, are the same triangle. They're parallel to each other, and then you see that you have your rectangles that kind of wrap around them and connect them. Okay, so that makes this a triangular prism. All right, triangular prism. So let's see, we have this one and this one to check on, and let's go ahead and check our faces and edges and vertices to see where this is going wrong or which one of these is right. So if we have a face here, 1, 2, and then we have 3 rectangles, 1, 2, and then this back side here, 3. All right, that is going to show us that there's 5 faces. So this one's going to be our winner here. Okay, let's just check our edges real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, check. And 6 vertices. 1, 2, 3, 4, 5, 6. Bingo. We're almost there. We're almost finished. Okay, now you have to slice these shapes and figure out what shape would be inside of it. If I cut this in half and showed the inside, okay, it would look like kind of like that. All right, and this shape on top, all right, would be a rectangle. Okay, moving on. All right, any ball that you could cut in half, right, you would get something like that, right? And this shape would be a circle. Okay, so now anytime you cut a shape parallel to its base, a cylinder parallel to its base or a prism parallel to its base, the cross section is going to look just like that base. Okay, so when you slice that open and have your right, it's going to be the same as the base, and in this case it'd be a circle. All right, is that it? We did it? Okay. Whew. Take a deep breath. Good luck on the test tomorrow, or on Friday. I think you're gonna do awesome. Hopefully this helped